Well, hey there, sixes. All right. So today we're going to be extending what you guys already know about area models and multiplication into the volume model. So first, I just want to recall what you've learned before about multiplying fractions using area models, and we'll do that in these first problems. And this is the intro video where I will finish the first one for you. So I'm expecting it is sixes Tuesday morning. You guys have shown up to class, and yeah, this is the first activity for Tuesday. So when we talked about these before, we talked about drawing area models in order to look at why fractions multiply the way they do. So if I have a rectangle that is 3/4 centimeters by 1/2 centimeter, and I want to draw an area model and use that area model to find the area, then first I need to have a rectangle. So, all right, some rectangle like this. And then I need there to be 3/4 centimeter on one side. Maybe I'll color code this. 3/4 centimeters, when we did these, we went great. So 3/4 says that I need to cut this into fourths, and I want 3/4 of those chunks. So that's 3/4 centimeters. 1/2 centimeters, well, 1/2 is like this. So there's 1/2 centimeters. So if this should work really well. Look at, this is the area that is 3/4, and this is the area that is 1/2. Then the area that is combined is this box in here, this purple box. So that's our result when we're looking for the area of those. What that meant when we originally were computing these, we looked at that and we said, great, that means what we have in the end is we have 3 boxes out of the total 8 boxes. So just saying there are 3 boxes here, and there are a total 8 boxes for 8. And that means when we multiply 3/4 times 1/2, then that's what we get, which kind of makes sense. If we take 3/4 and we cut all the pieces in half, then what we have is 3/8. So I want you guys to draw area models and use them to resolve numbers 2 and 3 here. And then 4 has a little bit of a challenge. Best of luck with it, and we'll definitely be talking about it when we get back together later on in class. So right now I want you to pause the video, try out 2, 3, and 4, and then when you're ready to move on to the next section, start the video again. Well, welcome back. I'm expecting that you paused the video, you tried out the rest of that section, and you're ready to submit that work before the end of the hour. So the next step, since we already have area multiplication, we can move that same model into a third dimension. So we'll be drawing the 3 faces of a prism with these dimensions. What is interesting is when we get a third dimension, you know we have to go from drawing area like this to making a depth, so that we end up with things like well, 3-dimensional prisms. So that said, in this case, when I have 3 dimensions here, I'm going to be drawing my dimensions. I'll say that's that dimension. Come on. Let's say that is this dimension, and this is this dimension. So that's kind of like length, width, and height, or however you want to think about it. Those are our 3 dimensions. So the way I've done this then, on the red side, I know I want 2/3. So I can say, cut that thing in thirds, and this thing is 2/3. Then on the blue, I want 1/2. So I can cut that guy in half and say that that is 1/2. And then the purple 3/4, so it's kind of hard to do with the perspective, but that turned out okay, 3/4. So then if I fill in the rest of this cube, we look at what we have, and I can see these things filling in that chunk there. So how big is that chunk there? Well, the area in front here is going to be 1/2 times 2/3, and the area on the side here is 1/2 times 3/4. And so if I want the whole chunk, I'm just like taking this front piece, and when I multiply it by 3/4, it's like it takes that front and it just like animates it across here and fills in all of that space. So we're looking at, this is 1/2 by 2/3 by 3/4. And we end up with, I would have 6 pieces out of, and I can see those 6 pieces because here this is going to be 2 by 3, like this is 6 pieces there and then 1 high. So it's like here, if I can do this, there's our 6 pieces. And then the whole thing, if I continue that and cut it apart, we're gonna have 4 times 3 times 2, that's 24 total pieces. And then very last, we should always reduce fractions. 6 over 24 is 1/4. In this case, centimeters cubed. I don't remember if I did units before, I certainly should have. So that's the idea of what I'm looking for here. In part, I want you to just realize that the area model extends into the volume model, and it's really the exact same idea. The other thing I want you to just enjoy, like practicing drawing 3-dimensional objects like this. It's kind of fun, and hopefully you get better at it as you go. So try out 2 and 3, they're very similar, and then in number 4 again, there's a challenge. So best of luck. Pause the video now and try them out. Welcome back, Sixes. I'm assuming that you tried out the last one. So now we're getting into like the more rote problem type of things. Down here, I'm just saying that we realize we don't need the model anymore. The model works to show why things multiply the way they do, but we've realized we really are just taking to get the volume and going base times height times width or depth or whatever you want to name your 3 dimensions. So in the case of this first one, if I'm trying out number 1 over here, I know I'm going to have the volume of that object be 5 4/6 times 6 1/2 times 5 1/2. And then from there, you have lots of strategies that you could use to go about this. If the numbers are easy, some number talk strategies might work really, really well. In this case, when I look at it, I think I would just go straight traditional and just change this like 5 times 6 plus 4 is 34/6 times 6 times 2 plus 1 is 13/2, just to say this would be like the traditional method, but your number theory should serve you really well. If you see easier ways to do things, do them. 5 times 2 plus 1 makes 11/2. And then I could reduce things if I see them, like 34/6 is the same as 17/3, and I think that's everything that reduces. So in the end, I would do 17 times 13 times 11 over, well, 3 times 2 is 6 times 2 is 12. And so now, well, I can multiply those. You can multiply them out or whatever. You should though, because we should have units on this. These are feet, so this should be feet cubed. As a simplified answer, I would also multiply these things out. I just don't want to waste your time with it because I know you're watching a video. So try out the next 3, and I'll just have a really quick note for you before you try the last section. So pause the video now and try out the next ones, and then when you come back, it'll be super quick. Welcome back, Sixes. The last chunk of this, I just wanted to note, if we have this volume formula, which is like length times width times height, or times base or depth or whatever, like I've noted, the same way we label all the dimensions. Well, then here we have different sets of information, but if we know the volume there, we can use that. If the volume is 512, and I know the length is 8 and the width is 8, and I don't know the height yet, well, then I can multiply those things. This is 512 equals 64h, and then I can solve and find that h equals, well, again, I don't want to waste your time. Not that it would take long, but I would divide those and have a final answer. And this one is in centimeters. Don't forget units. So, sorry about my terrible handwriting, but that's all I had for you guys. So try these out, submit what you've got at the end of the hour, and I'll see you guys in the next lesson today. Have a great day, Sixes.